Hello, everybody. Here we are. We are going to talk about the integumentary system. That's what you've been reading about and watching a Netflix episode about up until now. So the integumentary system mainly deals with skin. So we are going to talk about our skin in the integumentary system. Let's go. All right, our skin is considered the largest organ in our body if you are defining organ as two or more tissue groups grouped together performing specialized functions, which is how most people define an organ. This system includes our skin, which is mainly what we're going to talk about, our hair, our nails, sensory receptors, and some glands. We'll continue talking about glands when we talk about the endocrine system, but we will talk about some glands with the integumentary system as well. All right, our skin and tissues. This is the system's main function, helps to maintain homeostasis. Our skin provides a protective covering for our entire body, which helps maintain that equilibrium that we've been talking about all year. The protective covering helps to regulate temperature because we're not losing as much heat with that covering. As you may or may not realize, our skin also reacts when we are very warm and when we are very cold. So it helps maintain a specific temperature, as long as you're not getting hypothermia or something. Our skin can help us out with that. It also slows our water loss. So if we did not have this protective layer of skin, all the tissues underneath, our muscles, our nerves, our organs, would dry out really quick. And you do not want dry organs, let me tell you. Not good. Our skin also holds sensory receptors. Without those receptors, our nervous system would not be able to tell if we are hot or cold, if we are touching something we shouldn't, if there's pain going on and we need to move away, or if there's like a bad pressure. So these sensory receptors in our skin help other systems of our body do what we need to do. It also makes certain biochemicals that we need for day-to-day living. Our skin also helps us excrete some waste products, not all of them, but some of them. And a big one that we are going to learn about is how we get vitamin D, which is needed for many functions, but specifically for our bone development and our teeth. Without vitamin D, we would lose a lot of function that we already have. So thank your skin for doing all these things. Our vitamin D production is very important for our day-to-day existence. You should also be reading about this in that reading that was assigned to you earlier this week. So if you have not started that yet, now would be a great time to do it. You get some tie-in with the notes you're learning about today. We can eat this vitamin. You can take vitamin D pills. You can get vitamin D in different sorts of foods, but if you are not getting that in your foods, if you're not consuming it, our skin can also produce it, which is super helpful. During our digestive system process, our system makes a molecule called dehydrocholesterol, which is a long word and it's a complicated looking chemical. If you look off to the right hand side of your screen, that's what it looks like chemically. This is a molecule that our body, specifically our kidneys and liver, cannot break down. So they cannot take this molecule and turn it into things that are useful. So what our body does is our blood brings this molecule up to our skin, and when UV light or sun, the rays of the sun, hit that molecule, it changes slightly. And in this changed form, our kidneys and liver can break it down into vitamin D, which is something that we need for life, and it's something we can use. It's not harmful to us. So a useful bodily process for us there. So because of the UV rays from the sun, this molecule gets broken down into something we can use. Our skin can be broken down into three main layers. Our epidermis is what you see on the outside. It's the outer layer of your skin. Our dermis is that inner layer right underneath our epidermis. And we have a subcutaneous layer. This isn't truly skin, but it counts in the integumentary system. That tissue is directly below the dermis. Our outside layer does not have blood vessels. So the outer layer of our skin is only composed of stratified squamous epithelium, which is just flattened epithelial cells. In our epidermis, these cells grow and divide, and our old cells get pushed to the surface where they eventually die. So if you are seeing that you got some dry skin, it's feeling ashy, you can see like cells, maybe if you like rub your hand and you can see the cells kind of in the sunlight, that is those dead cells in your epidermis that are dead, dead cells in your epidermis that can just float away. You don't need them anymore. In the deeper level of the epidermis, we do get some nourishment from blood vessels in the dermis, but those blood vessels are not in that top layer. This layer is very protective. It is the main source of protection in our integumentary system. It stops water loss, so it stops us from getting super dehydrated from those sensitive tissues underneath. If there's an injury, a physical injury, this layer tries to stop as much as it can from major damage. Obviously, you can still get injured underneath that layer, but with it, we get a little more protection. So if you fall off your bike and you really scrape up your knee, that epidermis helps stop the super deep tissues from getting damaged. This is also protective from harmful chemicals. So if you get something toxic on you, there are some things that your skin can't protect you from, but most harmful chemicals that get on your skin, that epidermis stops it from getting too deep in your tissues and having like your blood vessels soak it up. So thank you, epidermis. Also keeps out pathogens. So if you get an injury or a cut, you put a Band-Aid on it or some sort of covering on it, so that way you're not susceptible to those pathogens that are existing outside of us. So your epidermis can protect you from those pathogens. The last big thing we're going to talk about with the epidermis is that melanin is produced in this layer. And melanin is a pretty cool chemical that our body can produce. Oops. All right, so melanin, if you do not already know this, is a pigment in our skin. It provides our skin color. What happens in our skin is we have these cells called melanocytes, and those melanocytes are what produce our pigment. And those little melanin pieces help us absorb UV rays. Without this, UV rays could damage our DNA. So more melanin means you have a less likely chance of your skin absorbing some damaging UV rays. Lighter skin means you might have to use some other types of protection from UV rays like sunscreen, clothing that covers you, hats, whatever. And all humans have the same amount of melanocytes. So that cell that produces melanin, we all have the same amount roughly. It is our genes that tell that cell how much melanin to produce. So there's a bunch of genes that play into our skin tone or our skin color. And those genes send signals to your melanocytes about how much melanin it should produce. So if you have very light skin or you have very dark skin, you have the same amount of melanocytes. What changes is how much melanin is produced from that cell. Things that can darken your skin or make those melanocytes produce more melanin are sunlight, UV rays, and X-rays. So if you are exposed to those rays stimulate production of extra pigment, which is why your skin gets darker in the summer, or if you go on a vacation to a sunny place, if you are soaking up those rays, those melanocytes are getting signals to produce more melanin. All right, the other layer, the second layer of our skin is called the dermis. It is located under the epidermis. And if you see this image over to the side of your screen, the boundary between these two is uneven. So there is, you can see these epidermal ridges, and they're pushing into our dermal layer. The dermal papillae extend into those ridges, which is what gives us that like wavy texture we see there. We have more of these ridges in our hands and our feet, or palms and our soles. It's because ridges leave a pattern when the palm and your fingers are like pressed against it. So when you are a fetus, a developing fetus, your hands at one point pressed into the uterine lining that you're developing in, and that is what helps form your fingerprints, which is why even identical twins have completely different fingerprints. Our genes kind of determine what type of fingerprint you are going to have, and then the pushing on that uterine lining is what makes the exact shape of your fingerprints. So no fingerprint is alike. If you look at, there's three main types of fingerprints. You can have arches, loops, or whorls as like the three main types, and there are some subcategories in there. But if you look at just these simple three categories and you look at your own fingerprints, you can determine which one you have. You may have more than one. I mostly have loops, got loopy fingerprints, and maybe a whorl in the thumb. So if I ever commit a crime and my fingerprints are all over the crime scene, that was foolish of me, because your fingerprints can be traced back to you, because we all have super different fingerprints. So check out your own fingerprints. Do a little self-investigation. What kind of fingerprints do you have? All right, besides forming fingerprints, our dermis also binds that outer layer, the epidermis, to our underlying tissues. So it keeps us intact so our epidermis doesn't just fall off. The dermis is made of fibers that give skin toughness and elasticity. So our dermis helps keep our skin from being super fragile and breaking on things. It also keeps it elastic, so it can kind of bounce back, especially when you are younger. There are different tissues that compose the dermis to help give it toughness and elasticity. The dermis is also special because there are blood vessels that are going on throughout that tissue, and those vessels supply all nutrients to our skin. This also greatly helps us regulate our body temperature. We also have nerve cells, and the nerve cell processes happen in our dermal layer. So when we were talking about reflexes, this played a huge part in how we have reflexes. Our motor cells are in the dermis, and sensory cells. So we've got impulses from the brain and spinal cord that travel to dermal muscles and glands. We also have impulses from sensory receptors. So when we touch something hot, that signal also goes to our brain and spinal cord. Without the dermal layer, we would not be able to react to our environment like that, which would be bad because if you were burning your hand on something, you wouldn't know. It would just burn up. And that is bad. All right, if you are someone that has tattoos or you want a tattoo, needles are injecting ink into that dermal layer. So you, if you've ever seen someone get a tattoo or you've got one, the ink is in a little gun attached to a needle. That needle is pushing the ink into your dermal skin layer. And it stays there because your dermal cells are not shed off like your epidermal cells. So if you are like seeing your hands are dry or you've exfoliated and there's like skin cells coming off, that's not dermal. That is only that top layer. That's only the epidermal cells. You can get tattoos removed, which involves shooting a laser at the ink molecules, and it shatters those molecules, and then your immune system can clear it out, which is wild to think about to me. So that's all we have for this intro to our integumentary system. We will pick up with our hair, nails, and some glands later this week. And hopefully it will be in person and I will have a negative COVID test and everything will be perfect. All right. Goodbye, everybody. We're soaking up those rays. Yeah.